Have you ever really stopped to think about how Java actually organizes information? Under the hood.
It's interesting, right?
The
Because it's not just one simple way.
Exactly. It feels like Java kind of speaks two different data dialects at the same time. You've got primitives on one side and objects on the other.
Hmm. Two distinct forms.
And today, we're doing a deep dive into something called wrapper classes.
Ah, yes. Java's a clever little solution.
Right. It's how Java bridges that gap between those two, very different ways of handling data.
It really is key.
So by the end of this deep dive, the idea is that you'll really get what wrapper classes are, how they work, and maybe more importantly, why they're just so fundamental in Java's object-oriented world.
Especially if you're aiming for code that's, efficient but also robust.
Definitely. Okay, so let's maybe unpack this from the start, the basic distinction.
The foundation.
Yeah. So first up, we have primitive data types.
The building blocks.
Right. These are like the absolute basics in Java. They hold simple, raw values directly in memory.
Think int for integers, like, say, 5.
Or double for decimals, like 3.14.
Char for a single character, maybe a.
And of course, Boolean for just plain true or false.
And the big thing about them.
They're efficient.
Yeah.
Really efficient. Lightweight, super fast, great for basic calculations.
Absolutely.
Yeah.
But, and here's the catch.
There's always a but.
Well, Java is, at its core, an object-oriented language. That's its whole philosophy.
Right.
And that means a huge chunk of its features, its libraries, its frameworks, they all expect to work with objects.
Okay.
Objects aren't just raw values. They bundle data and behavior together. Yeah. They're more complex structures.
And the problem is?
The problem is those super efficient primitive types, they just aren't objects. Yeah. They don't have that structure, those built-in behaviors.
Ah, okay, so that's the fundamental disconnect then. Primitives are fast, but they're limited when Java expects an object.
Exactly. You hit situations where you need an object and a primitive just won't cut it.
So the big question is, how does Java solve this? How does it make these two, totally different concepts work together smoothly?
Well, that brings us right back to wrapper classes.
The solution.
Precisely. They are Java's really practical answer to this exact problem. There's a classic analogy that works quite well.
Oh, yeah. Let's hear it.
Think of the primitive value, like, say, the number 5 is the actual gift.
Okay.
And the wrapper class, like integer in this case, is the gift box.
Ah, I see. The box makes it look and act like a proper object that you can pass around and work with in object-oriented ways.
Exactly. The wrapper class literally wraps around the primitive value.
Got it.
And it turns it into a full-blown object.
Yeah.
And there's a direct matchup for every single primitive.
Right. You mentioned there were 8.
Yep. 8 primitives, 8 wrapper classes. So int gets wrapped by integer.
Yeah.
Double by double.
Char by character. Boolean by Boolean.
And same for byte, short, long, and float. They all have corresponding wrapper classes. Byte, short, long, float.
And they're easy to access.
Super easy. They're all part of the core Java long package.
Meaning they're just always there, no special imports needed.
Correct. Always available.
Okay, that sounds incredibly useful, very flexible, but you mentioned trade-offs earlier.
There's always a trade-off in programming, isn't there?
Seems like it. So we're adding this box, this layer. It can't be quite as raw and fast as the primitive itself, right?
That's the core of it.
So that begs the question. If primitives are so blazing fast, why even bother with these wrappers? Why not just stick with primitives all the time?
That is the central question, really. And it gets right to the heart of why Java is designed the way it is.
Okay.
The need for wrappers comes down to what primitives can't do in an object world. First, and maybe the biggest reason, is compatibility.
Compatibility with what?
With Java's object-oriented features. Especially things like the collections framework.
Ah, like array list, hash map, those kinds of things.
Exactly. Those tools are built to work only with objects.
Right. I remember trying this early on. You just cannot make an array list in. Java simply says no.
It won't compile. But you absolutely can make an array list integer.
And that integer is the wrapper class.
Precisely. That's what lets you put those integer values into a dynamic list, manage them, sort them, all the things collections are good for. It unlocks so much functionality.
Okay, that makes perfect sense for collections. But what about that overhead concern I had? Does wrapping and unwrapping add a significant performance hit?
It's a really good point. Creating a wrapper object does mean allocating memory on the heap, which is definitely more work for the JVM than just putting a primitive on the stack.
So if you're doing it millions of times in a tight loop.
Yeah, if you're in a really performance-critical section of code, constantly boxing it into an integer and then unboxing it back,
Yeah.
you might see a difference. There's a feature called auto-boxing that makes the code look clean, but the work still happens.
So it's a trade-off. Speed versus object capabilities.
It's a classic one. Primitives to the raw speed and heavy computation. Wrappers, when you need that object functionality or flexibility.
Mm.
It's about choosing the right tool.
Got it. So compatibility with collections is reason one. What else?
Reason two, primitives are just values.
Mm-hmm.
An int42 doesn't do anything by itself.
It just exists.
Right. Wrapper classes, though, because they're objects, come with built-in methods. Useful behaviors.
Like what kind of methods?
Well, take integer. It has methods to convert the number to a string or to compare itself to another integer. Or, really useful, to parse a string like 123 and turn it into the integer value 123.
Oh, okay, yeah. That parsing method is super common.
Exactly. And character has methods to check if it's an uppercase letter or a lowercase letter or a digit. Double can do things like check if the value represents infinity or nan, not a number. Things that primitive double just can't do on its own.
So they package useful utility functions right with the value.
Correct. Reason 3 is also critical. Handling null.
Ah, the concept of nothing.
Right. Primitives always have a value. An int defaults to 0 if you don't assign one. A Boolean defaults to false.
They can't represent the idea of no value provided or value is missing.
Precisely. But wrapper classes, because they are objects, can be assigned the special value null.
And why is that so important?
Think about data coming from a database or user input. Sometimes a value just isn't there. Maybe a user didn't fill out an optional field.
Okay.
If you used an int for, say, age, and the user didn't provide it, you'd probably get a 0. But does 0 mean they're actually 0 years old? Or does it mean the data is missing? It's ambiguous.
Right, I see. But if you used an integer.
You could set it to null. And null clearly says we don't have a value here.
Yeah.
It's unambiguous. It allows for much more accurate data modeling and better error handling.
That makes a lot of sense, especially for real-world data. Any other big reasons?
One more worth mentioning is that some specific Java APIs or third-party libraries are just designed to work strictly with objects.
Like maybe GUI frameworks or certain database interactions?
Yeah, things like that. Sometimes the method signature just demands an object, and if you have a primitive value, you'll need to wrap it first using its wrapper class.
Okay, so summing that up, we need wrappers for compatibility, especially with collections, for the useful methods they provide, for handling null to represent missing data, and sometimes just because an API requires an object.
That covers the main whys, definitely.
So it's really about choosing the right tool. Primitives win for raw speed, simple math, memory footprint.
Mm-hmm.
But wrappers are essential when you need object behaviors, nullability, or integration with object-based systems.
Exactly. It's about context.
All right, so we've covered their boxes for primitives and the why compatibility methods, nulls. Now let's dig into the how. How does this wrapping and unwrapping actually work mechanically?
It's conceptually pretty straightforward. You take a primitive value.
Like our number 10, the int.
Right. And you essentially place it inside an object of its corresponding wrapper type.
So int 10 goes into an integer object.
Correct. And there's terminology for this. Putting the primitive into the wrapper object is called boxing.
Boxing, like putting the gift in the box. Got it.
And going the other way, taking the primitive value back out of the wrapper object.
That must be unboxing.
You got it. Boxing and unboxing.
Does the programmer have to do this manually every time? Like integer I equals new integer 10.
You used to have to do that quite explicitly, yes. But Java introduced a really convenient feature a while back.
Oh.
It's called auto-boxing and auto-unboxing.
Auto. So does it automatically?
In many situations,
Yeah.
yes. The compiler handles it for you. For instance, you can just write integer I10.
Oh, wow. So you assign the primitive int 10 directly to the integer reference I.
Yep. And the compiler automatically inserts the boxing operation behind the scenes, creates the new integer for you.
That's much cleaner. And auto unboxing.
Same idea, in reverse. If
Yeah.
you have an integer object, say my integer,
Yeah.
and you need to assign its value to a primitive int, you can just write int j my integer.
And the compiler automatically extracts the int value from the myInteger object.
Exactly. It handles the unboxing for you. This makes working with wrappers and primitives together feel much more seamless in the code.
That definitely lowers the barrier to using them. I can see that. Now, you also mentioned something about them being immutable.
Ah, yes. That's a very important property of all the standard wrapper classes in Java.
Oh.
They are immutable,
Meaning?
meaning once you create a wrapper object with a certain value, say integer 10 equals 10, that specific object will always represent the value 10. Its internal value cannot be changed.
So if I wanted it to be 11 instead, I can't just do 10.setValue 11 or
Well,
something?
there's no such method.
Yeah.
If you need an integer object that represents 11, you have to create a new integer object, like integer 11 equals 11.
Why did they design them that way? What's the benefit of immutability here?
Several benefits, actually. Immutability makes objects inherently simpler to reason about. Their state never changes after creation.
Oh.
This makes them automatically thread safe. Multiple parts of your program can safely access the same integer object without worrying that one part might change the value unexpectedly while another part is reading it.
That's huge for concurrent
Yeah,
programming.
it is. It also makes them reliable to use as keys in things like hash maps, because their hash code, which depends on their value, will never change once calculated.
Predictability.
Exactly. And besides just holding the value, these wrapper classes often have other useful bits.
Like what?
They often expose helpful constants related to the primitive type they wrap.
Mm.
For example, integer.max value gives you the largest possible value an int can hold.
Oh, right. And integer.mn value for the smallest.
Yep. Or double.nan for not a number, double positive infinity, things like that. They package useful metadata right onto the class itself.
Very handy. Okay, this is starting to form a really clear picture.
Good.
So just to recap for everyone listening, including you, wrapper classes are really that vital bridge in Java. They let our simple, efficient primitive values play nicely in the bigger object-oriented sandbox.
They enable primitives to participate fully.
They give us flexibility, they give us access to helpful methods tied to the data type, and crucially, they let us handle that idea of no value using null.
Which is essential for robust applications dealing with real-world data.
So for practical use, when should you reach for a wrapper, and when should you stick with a primitive?
The rule of thumb is pretty clear, I think. Use wrapper classes when you absolutely need an object.
Like for collections, arrayless integer, not arrayless int.
Exactly. Or when you need to call one of those utility methods, like integer.parseInt.
Or when the value might actually be missing and you need null to represent that.
Precisely. In those cases, wrappers are the way to go.
But otherwise,
Otherwise, if you're just doing straightforward math, lots of calculations in a loop, and performance or memory usage is a key concern, stick with the primitives. Int, double, long, they're generally faster and lighter.
choose the right tool for the job. Makes
Yeah.
sense.
It usually does in programming.
Okay, this has been incredibly insightful. Before we wrap up, maybe a final thought for our listeners to chew on.
Well, thinking about this whole primitive versus wrapper thing,
Yeah.
this idea of trade-offs,
Yeah.
it makes you think, doesn't it?
Mhm.
We saw how Java uses this wrapper concept to add flexibility and object capabilities to simple values, even if it costs a tiny bit of raw efficiency.
Right.
So the question to ponder might be, where else in the technology you use every day, or even just in systems around you, might there be similar wrapped solutions? Things that seem simple on the surface, but have a hidden layer, adding functionality or compatibility, maybe bridging two different ways of doing things.
Huh. That's interesting. Looking for those hidden layers that smooth things over, sacrificing a little raw speed for greater usefulness or elegance.
Exactly.
Yeah.
Where else are those clever bridges being built? Something to think about.